Hello everyone, D. Alfred Ostrowski here. Welcome to day 11 of my 20-day Ethereum blockchain challenge. In this recording, this is going to be the part 2 of the to-do list decentralized application, or DAPP, right? So to get all the background, you might want to take a look at the prior video, the day 10, where I introduced the smart contract. We invoked it from the command line of Hardhat, and we also ran a number of assertion tests on it. In this video, I'm going to be running it as a complete DAPP, and I'm going to run it first, and I'm going to run in the same fashion as I've done the prior decentralized applications with React.js. And as usual, everything's documented, and all the details that are omitted are covered in the README file they're alluded to, and they're also presented in great detail in the prior associated videos with the challenge title. So let's get started. As usual, I got C5 instance up and running. I have everything up and ready to go and configured. And again, I'm following through and talking through my instructions. I have a couple of terminals that I brought up here, and I'm running it, most importantly, out of the project directory. So I'm just going to continue on. What I did do is I've already configured the Hardhat config file, and I've set the DNS appropriately. You want to make sure if you're going to shut it down and bring it back up. Also want to point out, at times I've seen connection issues going to the Amazon instance. You want to double check the security rules, and I've gone through this in prior videos. If you still have a continuing problem, you might want to cycle through the instance. I've seen on rare occasion, and I cannot duplicate it at will, where I cannot access the instance. It's giving me connect issues, and I've just shut everything down and started back up again. So it may be something on the Amazon side. That's my assumption. It doesn't happen frequently, and it is intermittent. So that said, let's get started. And again, just clicking through my instructions, and again, everything is going to be included at the bottom of this video, as well as all the references to the prior resources. So I've gone to the Hardhat config, you double check the contracts, we went through that. So I'm going to start up the Hardhat personal blockchain, and I'm going to bring in the npx Hardhat node and copy in my DNS. Pull it in here. I want to make sure that I'm copying the right one, right? So give that a second to start up, and it's start up. I got my 20 counts as usual. Next, I'm going to do the deployment. So I'm going to do that on top of it, and you'll be able to see it come up appropriately in the background. So I was able to deploy the contract. So it's been deployed and everything's ready to go. What I'm going to do is run through the DAPP, and we're going to invoke it from the browser, and then I'm going to break down the React.js code that I used to make it happen, and about half of it you should be familiar already, right? Because we've gone through this incrementally, right? With the prior video, hitting it from the command line, between that and insertion testing, we already have most of the dynamics covered. However, there are some extra issues. So I got a couple warnings here. The provider and browser provider. In this case, I disabled the MetaMask just for efficiency. You can easily go back to that. I have videos how to hook up MetaMask. However, with the to-do list application, I don't have a lot of intensive engagement with MetaMask as I did, let's say, with the payable contracts. So in this case, I'm just going to omit it just for efficiency. We're going to be going back to that, especially in applications that are going to be dealing with more issues of monetary means outside of just deployment and issues like that. So I got my React application is up and running right now. So I can pull in a browser and I can invoke it. Again, I like to use Chrome. You should be able to use anything that you want. And here I've pulled up Chrome, and I'm going to, I don't have to, but I can put in the, grab that DNS again. Bring up the developers console, which I like to use. Okay. It's a great way of troubleshooting, and you can use that console log and log any of the variables and step through. So here's the to-do list. Bring up the developers console. Not necessarily really need to use it, but we can take a quick look at it as we run through some of it. I have a few variables still being presented here. And again, this is a good bridge, okay? You may be working through, as I do, sometimes through the console and back to the React application if there's something that I want to troubleshoot between the two levels. And again, this is a good point to look at your variables and step into it and match it to the line of code. So let's just enter some tasks. I have a simple text box and a button to add that task to the blockchain in the background. And I'm going to kind of pull this up in the background a little bit here so you can see it scroll by as we're updating it. So I'm going to say do laundry as a task. And I'm going to add that. This is going to push it to the screen with a bullet point, also with a button that I can hit to do the toggle on the smart contract. Add another task, walk dog, add that, that'll be pushed to the screen. And then I'm going to say, let's say take out trash, okay. And I can go on and on and on and test this, okay. So I have my tasks that are pushed to the screen. You notice I didn't have to, you don't want to have to continue. I've seen some applications where you have to keep continually refresh. You want to push to the screen, and we're going to go through that as I work that through with the React.js code. So I can click on any of these to complete. And in this case, you notice it grays out the text, and it also changes the button to undo. So I can toggle that task again. You can see in the background that it's updating the smart contract appropriately, and I can do that to any of these, grayed out, and correspondingly I can reset them back to a viable task to be completed, and I can add to that list and go on and on. It's not immediate, okay, because it's checking on the events, and that's it. Basically, I can run through that, and if I do a complete refresh, and the whole purpose of doing that is I can, again, run my diagnostics as I usually like to do. I can put it with using the console log, and we'll go through the smart contract for the few points where I did leave that in there. But I'm here, I'm relying on events as well as reading the blockchain directly, and let's go through that in a second here. But you've seen it run, and again, I like to see it run before I talk about it. I don't want to talk about something that's not going to work appropriately, right? So let's go to the only difference I have here is I have the app.js. Now I've seen implementations of to-do lists and everything else related to it, okay, with a more expansive interface, and they refactored the React into a number of separate components. And in my case, for an application this small is a little bit of overkill in terms of the design. So I like to put it all in a single app.js file. That way it's easier to read for me. And again, purpose of all of this, okay, very few are just going to be implementing this in a production environment. It's going to give you a lot of ideas and a lot of extra tools and examples for you to expand to do your own smart contract development and borrow from existing examples. So let me step through this line by line. Here I do the imports. I'm pulling in React, and I'm pulling in two hooks. Use state and use effect. As I mentioned before, I've gone through this a little bit more detail in some of the prior videos. Use state is going to allow for global access to the associated variables, and it provides a means of setting a set method, if you will, okay, to be able to reset that variable. And use effect is going to support the means of initializing. It's going to produce a side effect where upon the invocation of this app, It's going to run use effect in the background and allow for the means of resetting it upon the refresh. Okay, so here I have bring in ethers. Okay, ethers.js browser provider. Okay, it's going to allow for the browser interface and the wall connect if I choose to plug that in. Get to it in a second. And I bring in the ABI and address in similar fashion, okay, that I've done before. And this is supported by the deployment script. And I like to, as I've done before, I like to pull in the to-do address as a file. That way I'm not going to play with the hard coding. It's bad enough they do with the DNS, but it's kind of a moot point if I set it as a config file to pull in the DNS, because I got to change one file one way or another. In this case, it's automatically written with the deployment, since the deployment address is a part of the deployment activity. So as the fact of running that deploy, and you can look at the deployment, it works in exactly the same fashion as even the day 2 example and all the examples that work with decentralized applications beyond that. So here the main function is function app, and within that I have 3 use states, one for the provider, the task for my smart contract, input, the text input for the task, the contract, and the contract itself. Okay. Next, I have the use effect. And again, this runs in the background as the app.js is initialized or refreshed. We just saw this run when I completely refreshed that. And I didn't have to, but I did it just so you could see the console logs that I have here and get an idea of the dynamic and when things are executed. Okay, so again, to me, the console log allows for a great means, especially if you're not really experienced with working with React, or working with React in conjunction with more asynchronous networks, like with blockchain type networks. Okay, it gives you a better idea to get an idea of what happens when, and then most importantly, what variables are presenting at that time. So I have an initialize function that is defined. And this is when within the context of use effect, which begs the question, why don't I just take the code that would be initialized and put it in use effect? Here I define it and then I invoke it just below that. I need to run this as an asynchronous function. I'm going to get some type of errors or problems. Okay, so interestingly with React hooks, I can't run React hooks as asynchronous processes. So that's why we have this programming convention of setting up the initialize appropriately. Next, I use JSON RPC providers I've done in the past, okay, and I explicitly bring in the DNS 8545, and that's invoking my personal blockchain. And I load that into Web3 provider. Now, again, if you want to go through the MetaMask, which I'm not going to do in this video, you can go back to one of the earlier videos in this series where I go up through the MetaMask, and moving forward, again, we're going to be doing more allocation of funds and taking a look at the counts here. I don't really have to pay attention a lot to it. We know with the deployment, it's going to take some money out of the account. That's pretty much it. It's going to do a little bit money being withdrawn from the account if I write to the blockchain, okay, but we're not moving a lot of substantial funds, okay. It's not like a gambling application, or in the future doing a fundraising type application. We're going to allocate funds. So I do the set provider. This is going to do the use state hook and set that provider variable appropriately, okay, whether I'm going to be using what's commented out, the MetaMask, or the JSON RPC provider that explicitly makes the contact. And if you comment one, you're going to have to uncomment one, you're going to have to comment out the other, right? You can only use one. I'm sure you realize that by now. So here I'm going to grab the signer using the get signer method, and I'm going to use the ethers library to grab the smart contract and pass the signer in as a variable, and I'm going to set that through the variable to-do list contract through my use state, and that is going to allow access throughout the remainder of that React application. Next, I'm going to grab the account. We did this from the command line, and it works in very similar almost exactly the same fashion. And then I'm going to initialize a list of loaded tasks, and I'm going to iterate from that count, starting from 1, right? Because we incremented the smart contract from 1, and I'm going to load tasks into pushing that into the loaded task list. And then you can print that out, and I did that in the background, and we saw that run. I'm going to set that to task, and through the set task, and it's going to be able to be accessed throughout the remainder of the React application, because you got to remember this is all in the initialization script, and it's only run once. Next, I have to-do list contract, and I'm going to establish 2 listeners. This is for the events. One is for the created and for the task completed events. Remember, we're writing 2 ways to the blockchain. We're writing to the actual blockchain and also to the event logs, creating those events. And this sets up a listener. You can think of it as a web server, okay, similar fashion. And it's going to grab when a task is created. Anytime I went through that task, it wrote it to the blockchain and also created an event, and that contained the ID and the content. Here, I'm going to set tasks, and if you note here, I have previous. Previous is loaded with the existing task list. So you notice this is a pre-initialized variable. So when you look at previous in this context with the on listener, it's going to contain all of the prior events. Okay, so here I have within the block of code, I iterate through previous, and I match task, the ID, and the triple equal sign for equivalence matched type, and I strongly course it to type here with 2 strings that I'm matching the ID of the event to the existing task. And if it exists, okay, then I return previous as it is if it's a new, and this is capturing a new event. Okay, if I have a new event, then I'm going to add that to the dot previous is the existing list of tasks, and I'm going to initialize that or add on to it, okay, with the 3 pieces of information: ID, content, completed. And that's recorded as that struct, okay, with the brackets associated. So this is a little bit involved here, but again, once you start thinking about exactly what is going on and how that's being accomplished, and we just want to remove any duplicates. It may beg the question, why would I have duplicates? With the use of, and this goes back to the nature of events, okay, and how they are leveraged in the context of the Solidity smart contract. So there's a lot of things, a lot of dynamics going on behind these definitions that seemingly are a little more simplistic than they appear to be, okay, in the context of their implementation. But with events, they are not indivisible actions, okay, and they can be subject in the context of an asynchronous environment of being regenerated in times or using some type of error recovery. So in that case, there could be additional pieces of additional events being generated, and you want to filter that out so you don't have more than one task when you initialize that task to the ID. So that's the purpose of matching it, and here we are essentially filtering through these 2 lines of code with the previous sum and the match. We're filtering out any additional events so we don't have a duplicate, okay? And that's important to keep in mind. We're doing that with both the events, okay? And that's the nature, right, of the blockchain. It's once and only once, and has more of an indivisible nature. And this is contrary to the dynamic, and I alluded to this in the prior video, that again, the more of these little examples, the more that we work with, the more the appreciation that you have for what's going on with events that are being generated from the smart contract, as well as directly writing to the blockchain through variables. And identifying their complementary nature, okay? And this is what we need to do to leverage this, okay? Because we want to be able to establish listeners. We want to push events. We don't, purpose of having this in the first place and relying on events is we don't want to continually refresh. If we took this out, it's still ready to the blockchain and still load it, but you'd have to continually refresh your screen. And though it wasn't immediate, you notice when I ran, and it's how I wanted to run it before talking about this, right? When I run the application, it would push the event to the screen, which is super convenient, and it looks a lot more professional than it would otherwise. Next, I have the task completed. Works in a very similar fashion. I establish a listener for that task completed event. The toggled event, I may be turning it on or off. And in this case, I have previous are the establish task completed events. And in this case, I'm going to add a new update where it contains the completed variable. And if you note here, I had completed a false here. I've completed to the completed variable. Big difference, right? Because this allows me to complete and undo the task. And I've seen other examples on the web where you just mark off the listen. That's it here. It kind of gives you a little more capability where I can set it off and on and adjust it appropriately. Okay, so here I match it again between the two IDs, and I establish that if I match the appropriate ID for the task completed, I'm going to add the appropriate record with the status structure, okay, if you will, okay, with the completed status. If it doesn't match and it was never set before, there's no event, no one clicked on it being completed, then I just return T. T is what? T is everything that was initially represented as. And that's it, okay? That is pretty much all the initialize method, if you will. And that use state, I have return, and I have a remove all listeners. I can remove the listeners, just doing a little cleanup here. You just don't want these sitting out in memory. And here I have the references to the to-do list address and API, and that was initialized and import. And I'm almost done with the JavaScript here, okay? So here I have the create task and toggle task. And again, once again, we're super familiar with this. It looks exactly the same fashion that we did from the command line. That's why I like it. That's why I like doing that, right? Because we're already familiar with a lot of this code, and you should be already if you've gone through the prior video. I'll break this down a little more chunks here, right? So here with create task, it essentially, if you don't have a contract, it's going to return, okay? And it's a little more of a formality. And here I grab the transaction address, I do the create task, invoke the contract, and I wait for the transaction to complete, and then I initialize out the variable, and then the toggle calls toggle completed in the similar fashion of the tx wait. All I have left is the HTML, guys. Okay, so here I have, you can see the H1, the to-do list. I have my input text box as input, and I have an onChange event. When I hit the button, it invokes the create task appropriately, and below that, I map through the tasks. I'm pulling out tasks one by one, and it prints out to the screen. And in this case, it checks the completed variable, and it grays out if it's been marked as completed. Otherwise, it maintains it as black and then prints it out here. And then it follows that up with a one click, and also is going to test. It's going to set the button to undo or complete, and that's it. Okay, so it's not the, it has the utility there. It's not the fanciest in the world, but here we're not concentrating on HMI. I may have other videos that do a lot more detailed into more full stack type content and HMI, but here we want to just go through the basics and give you the means of engaging with your smart contract. And when you look at it from as a complete decentralized application, again, you have a greater appreciation of the dynamics of Solidity and how it's leveraged in the entire blockchain environment. So that's it. Hope this helps. See you on the next video. Thanks for listening. Take care. All right, bye now.